Okay, in this video we are going to use the quadratic formula, and let's review quickly how all the methods that we have to solve quadratic equations. One of the methods that we have is that we could graph the quadratic equation and see where it crosses the x-axis. That gives us a good visual representation, but sometimes it's hard to find the solutions, especially if they're fractions, to see exactly where the quadratic is crossing the x-axis. And then some quadratic equations could be factored, and that's a fairly easy way to solve it. So if we can factor it, we usually do. Another way that we had just learned was taking square roots, and that occurs when there isn't any b term or the linear term. That would be if, for example, if I had something that would be something like x squared minus 4 is equal to 0. There's no x term, so you could solve that by taking the square root of both sides. Then we learned a method that works for every single quadratic equation called completing the square. And what we're going to do now is learn the quadratic formula, which also works for all equations. Now, the quadratic formula actually comes from completing the square. You don't have to know how it's derived, but I just want to show you that it is derived by completing the square. Here's a quadratic equation in standard form, ax squared plus bx plus c equal to 0. And then notice that if we move the c over to the right, and we use a technique like completing the square, that with a lot of algebra we get done and we end up with the quadratic formula. So once again, the quadratic formula is just what happens when you use completing the square on this standard equation form up here. Okay, so let's talk about the quadratic formula. The first step you always have to have is you have to have a standard form equation. And that would be ax squared plus bx plus c. Now, one of the values may be missing, like c could be missing, but basically is you can't have any, nothing like this, like x minus 3 squared equal to 0, anything like that. That's not in standard form. And the other side has to be a 0. So let's take a look at the quadratic formula. The quadratic formula is the solutions of x are equal to a minus b plus or minus the square root of b squared minus 4ac all over 2a. And notice this plus or minus, that's going to mean that I could have two solutions, which makes sense because we know that a quadratic can cross the x-axis in two places. We have to be really careful if we're just entering this into the calculator, not showing a lot of work, that a lot of times, let's say b would be negative. And so what people have a tendency to do, let's say, is if you're entering the square root into your calculator, you'd go, and let's say b is a negative 5, people would enter in a negative 5 squared like that into their calculator, and that's not going to work. This is going to say 5 squared and then put the negative. What you would have to enter in is you would have to enter in something that looks like this, a minus 5 squared, and then of course you would enter in the 4ac. So we have to be careful when we're actually using calculators to solve this when we're not showing every step of our work. Because let's go ahead and solve some. Now, the textbook had broke some of this down into situations with two real solutions, one real, stuff like that, and the different kind of solutions I could have. And I may not work all the problems, but I will work some of these. So let's go ahead. This one should have two real solutions, so let's give it a shot. So the first thing I'm going to do is I'm going to make sure that this equation is in standard form. And to do that, I'm going to move the 5 over by subtracting 5 from both sides. So I'm going to have x squared plus 3x minus 5 equal to 0. And then I'm going to list the a, b, and c because I don't want to always keep a lot of stuff in my memory. So I'm going to just say a is equal to the 1. That's the coefficient in front of x squared. B is equal to 3. And c is equal to a negative 5. Now let's put these into the quadratic formula. Okay, so the quadratic formula is x is equal to a minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 1. Okay, so let's go ahead and start simplifying that. So next step, I will have x is equal to a minus 3 plus or minus the square root of 9. Now I have a minus 5 times 1, that's a negative 5, times the subtract 4 would be plus 20, all over 2a. X is equal to a minus 3, wait a second, I forgot to substitute a, that would just be 2, negative 3 plus or minus the square root of 29 all over 2. And the square root of 29 cannot be simplified any further, so that would be one way I could leave it. Another way I could write it is I could say x is equal to a negative 3/2 plus or minus the square root of 29 all over 2. And you would actually have two solutions, a negative 3/2 plus the square root of 29 over 2, and a negative 3/2 minus the square root of 29 over 2, but we would just leave it like that. Okay, let's try another one. Actually, let's jump down to a different kind, and then maybe I'll come back and work some more. So this one, it says I should have one real solution, and let's see how that works. So I'm going to go ahead and write this in standard form. So I'm going to add 13x to both sides. So I will have 4x squared. If I have a 13x over here, I'm going to add 13x. Actually, let me go ahead and just write what I had. Plus 3x, and now I'm going to add 13x to both sides. And I'm going to add 16 to both sides. And of course this side will be 0, and simplifying the left hand side I would have 4x squared plus 16x plus 16 is equal to 0. Now the next step you don't have to do, but if I want to work with smaller numbers, I could consider factoring out this 4. And it really wouldn't matter at all in the final solution. So let me just go ahead and try that. So what I have is, notice that I have 4x squared, I add these, I got 16x plus 16 equal to 0, and I could factor a 4 out. Remember, you don't have to do that. You could just, well, let's continue. I had an interruption there. So if I wanted to, right now, I could specify A, B, and C, and that would be A would be equal to 4, B is 16, and C is 16. But if I factor a 4 out, and I would have x squared plus 4x plus 4 equal to 0, and then if I divide both sides by 4, I would have x squared plus 4x plus 4 equal to 0. In this case, I would have A equal to 1, B would be equal to 4, and C would be equal to 4. And I could use the quadratic formula on that. And I would get the same answer. I'm just going to have smaller numbers, so at the end there'll be that less simplification to do. So let's go ahead and use the quadratic formula. X is equal to a minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's going to be equal to a negative 4 plus or minus the square root of 16 minus 16 all over 2, which is equal to a negative 4 plus or minus the square root of 0, which would just simply be equal to a minus 4 halves. So notice that because what happened underneath the square root became 0, I've got plus or minus 0, so I really am only going to have one solution, and that solution is going to be equal to a negative 2. Okay, let's look at another problem, and this one's going to have two complex solutions. And so let's go ahead and put it in standard form. So that would be a minus x squared plus 4x minus 13 equal to 0. If I wanted to, I could factor a negative 1 out, so I'm not going to do that. But if I wanted to, I could factor a negative 1 out and say, okay, that's a negative 1 times x squared minus 4x plus 13 equal to 0. And then I simply divide everything by a negative 1, and I would have x squared minus 4x plus 13 equal to 0. And I could use the quadratic formula on that, and I would get the same answer. Notice how the signs have changed on all the numbers. But because we haven't done one of these that has a negative on the x squared, let's go ahead and work it out this way. So a is equal to a negative 1, b is equal to 4, c is equal to a negative 13. So let's go ahead and plug those into the quadratic formula. X is equal to a minus b plus or minus the square root of b squared minus 4 times a negative 1 times a negative 13. Continuing, there was a lot of background noise there. So anyway, so let's go ahead and simplify this over 2a. So that would be 2 times a negative 1. So I have a negative 4 plus or minus the square root of 16 minus, now I have a negative 13 times a negative 1, that's a positive 13. Positive 13 times the subtract 4 would be minus 52 all over a negative 2. That would be a negative 4 plus or minus the square root of a negative 36 all over a negative 2. Okay, so let's continue. X is equal to a negative 4 plus or minus the negative on the square root will come out as an I. The 36 is a 6 plus or minus 6I all over a negative 2. Now that's not simplified. What we really want to do is always express a complex number in standard form. So I'm going to write the real portion. That would be a negative 4 all over negative 2 plus or minus the complex portion, which would be 6i all over negative 2. Now simplifying that, we would have 2 plus or minus (3i). And the reason I only put 3i, notice that this would be a negative 3 on the negative 3i, but because it's plus or minus, regardless of which operation I choose, it's always going to still be plus or minus, so I can just forget about that negative on that 3i. Okay, let's go down to another topic. This is something called the discriminant. And the discriminant is a portion of the quadratic formula. And all we use the discriminant for is to determine the number of types and solutions that we're going to have. Okay, so let's take a look at that. The actual discriminant is the part of the quadratic formula that is under the square root. So let's go back up real quick to the quadratic formula. And it's the part that's under the square root. Now, if this would be a negative under the square root, I would have complex solutions because the square root would be negative. If it would be a positive number, then I would have two positive real solutions. And you could see that if what's under the square root was 0, I would have b plus or minus 0. So the plus or minus would be plus or minusing a 0, and I would only have one root. So let's go ahead and see how that works. So here's a summary of that. If we have b squared minus 4ac, now be careful on this. The discriminant does not include the square root. All I need is what's under the square root. So don't put the square root over b squared minus 4ac. That would be wrong. So b squared minus 4ac, if that's greater than 0, that means what's under the square root is going to be greater than 0. I'm going to have two real solutions. I could see that they'll cross the x-axis someplace. If I have b squared minus 4ac is equal to 0, exactly equal to 0, then I'm only going to have one real solution. The quadratic equation is going to, the quadratic curve is going to come down and touch the axis in just one spot and go back up or down. And then we have the situation where b squared minus 4ac is less than 0. That would produce a negative under the square root, creating two imaginary solutions. The quadratic formula or the quadratic curve would never touch the x-axis. So let's go ahead and use the discriminant here. And what we're going to see is we have x squared minus 6x plus 10. And let's go just ahead and set that equal to 0. And let's go write the values of a, b, and c. A is 1, b is a negative 6, c is 10. So the discriminant b squared minus 4ac, that would be equal to b squared. That's going to be a negative 6 squared minus 4 times 1 times 10. That would be equal to 36 minus 4 times 1 times 10, 40. That would be equal to a negative 4. So what I would have is this value of discriminant is a negative 4, and I would end up with two complex solutions. Okay, let's go to the next one. So in this one, a is 1, b is a negative 6, c is 9. Now remember, you always have to have them equal to 0. In this case, we don't have to move anything over to the left-hand side. But remember, be careful to do that. So the discriminant is b squared minus 4ac. So b squared would be a negative 6 squared minus 4 times a times c, which would be equal to 36 minus 36. That's equal to 0. So the value of the discriminant is 0. That would be one real solution. In the last example, I think, nope, there's a couple more. So the last example is going to be where a is 1, b is a negative 6, c is 8. Putting that into the discriminant, b squared minus 4ac, a negative 6 squared minus 4 times 1 times 8. That would be a negative 6 squared is 36 minus 32. That would be equal to 4. So what we have is we have a positive number, so this would be two real solutions. Okay, I'm going to skip down to this last problem, which is a kind of different kind of problem. Notice I've skipped quite a few of these examples because I think you can, by working just a couple of examples like that, I think you get a general feeling for it. And I may work some more examples in class, but I don't want the video to be too long. So this next one says find the values for a and c so that x squared plus 4x plus c equal to 0 has just one real solution. And we could do this for whether it says two real solutions or two imaginary solutions. The main thing we have to do is we have to set it up so that we get the discriminant equal to whatever the type of solutions it says. So if I have a situation where I have one real solution, that must mean that the discriminant, which is b squared minus 4ac, that would have to be equal to 0. So let's go ahead and plug the values that I have in this equation up here into b squared minus 4ac. So b squared, b is 4, so I have 4 squared minus 4 times a, and of course a is just a, and c is also a variable that I don't know yet, is equal to 0. So 4 squared minus 4ac is equal to 0. Let's move the 4ac to the other side by adding 4ac to both sides. Let me redo that. I have 16 minus 4ac, and then I'm going to add 4ac to both sides. So what I'm going to end up with is 16 is equal to 4ac. Now divide both sides by 4, and I end up with that 4 must be equal to a times c. So I know that a and c are equal to 4, so I could pick any value that I want that equals that. So let me just say a will be equal to 1, c will be equal to 4, because it also asks me to write the equation, and so it could be one of many equations. So if I say a is equal to 1, that would be a 1x squared, so I have x squared, plus 4x plus the c value, which is 4, is equal to 0, and that could be one of the equations that I could write. The last problem is just like that one, so I think we're done here.